The Durbin-Watson statistics and autocorrelation. What our goal here today is to explain how to use the Durbin-Watson statistic, if you are given it, to determine whether or not you have a positive or negative autocorrelation. Now, let's go ahead and look at our example problem down here. It says Harvard College of Business investigated a number of students who enrolled in Business Analytics 2650 classes. They developed a linear relationship between successive semesters and number of students. The enrollment data is provided below, and the Durbin-Watson statistic is 0.921. So in this example problem, we are actually provided our D in our equation, which is this right here. Sorry for all this extra writing. I just explained this and made an error, so I'm just doing it again. But this is our formula, and for all intensive purposes for this video, we're going to assume that we do have D. Okay, so which is 9.921. So using this information, we want to find our DL and our DU. Okay, but first we need to figure what information we can gather from the problem. Now here is our table over here. As you can see, it is semesters and number of students. We're going to assume that the semester number goes all the way to 20, and now we have our variables. Now as you can see, it looks like there's two, but our K, which is what we want to know, is our number of independent variables. So our semester is going to be our independent variable because the number of students is dependent on the semester. So using this information, we're going to have a K, or our independent variable number, as 1. Assuming the data points go all the way to 20, we will have N equals 20. And in our first question, it says assume an alpha level of 0.01. So that will be our alpha. So now, with this new information, we can go into the table. Now I apologize that this is not rotated 1 degree clockwise, but this is what we have to work with, unfortunately. So if you just turn your heads to the left, you will see that this half of the table is for an alpha level of 0.05. That's not what we are interested in. We are interested in this half of the table for alpha 0.01. Now, one thing to note is that this far left is our N. So we will go to 20 up here, and then we will follow it all the way to the 0.01, and up at the top it shows our K. Alright, so that gives us a DL value of 0.95 and a DU value of 1.15. So with this new information, we can go ahead and plug that in and answer the first question. Okay, now these are the values that are going to tell us if there is a positive or a negative autocorrelation. And it can also tell us if these tests are inconclusive, which I will cover in another video. So the first question is there evidence of positive autocorrelation? Now I've already filled this in, like I said, because I just solved this problem. I'm just doing it again because I messed up. So let me erase some stuff real quick, just to clean it up. I guess it really doesn't matter too much. Let's get on with the video. So here we have 3 possible ways to test for positive autocorrelation in this first half right here. So to test, if D, which is our 9, let me start that over. So D, if D is less than our DL, which is DL, and if we plug these numbers in, so if 0.921 is less than 0.95, which it is, then there is evidence of positive autocorrelation. Okay, so we want to go ahead and put in yes. Now, if this wasn't the case and we wanted to test for negative autocorrelation, we could do that just as easily. And what we want to know for this one is we actually use the integer of 4. For whatever the reason is, that's just the way you test it. So that's how we're going to do it. So if we want to test if it is negative, we're going to test if D is greater than the sum of 4 minus du. And so we plug this in. If 0.921 is greater than 4 minus, our D value is 1.15, which gives us about 2.85, I'm assuming. So obviously 0.9 is not greater than 2.85. So this is incorrect. So there is no evidence of negative autocorrelation. And there are a few other things you can do to see if the test is inconclusive or if there is no evidence. So this is my video on the Durbin-Watson statistics and autocorrelation, and how to find if there's evidence for a positive and a negative autocorrelation. I hope you have learned something, so stay tuned for next week's episode where we discuss linear regression.